Hello, my name is Roshan, and together with Bilal and Ashwin, we are going to talk about on the research paper Natural Language Interface to Database by Regular Expression Generation. Introduction. Natural Language Interface to Database is a system that translates a given natural language input into a database query. It is a widespread and open research problem in the field of natural language processing that started in 1950s. A database contains a collection of important data in an organized way. The data can only be accessed or modified using structured query language. SQL is a language with complex syntax which people with limited knowledge around the field will find overwhelming. NLID develops a common interface system that allows the commoners or non-technical people to get their required information from the database using natural language input. The obvious advantage is that it makes computer interface easier for the use of general people. Because of this, people will be able to communicate to the computer in their own language instead of learning a specialized language or commands. By automatically converting NL to SQL, NLID removes the necessity of end users to employ sophisticated query languages like SQL. NLID system has two components. One of them is the linguistic component, which is responsible for translating natural language input into a formal query and generating natural language response. Another one is the database component, which performs the query operations from the database and NLID system. The questions are submitted and then translated into statements in the formal query language. Once the statement is formed, the query is processed by the DBMS in order to produce the required data. This paper presents a new approach of NLID based on pattern detection using regular expression. The goal is to design an interface that will take English natural language input and shows the output extracting the appropriate data from the database. The system works by matching the natural language input with the regular expression pattern, and if they match, the SQL is formed and then the appropriate data is retrieved from the database. Related works. There are many approaches used for developing NLID, such as pattern matching, synthetic model, semantic model, intermediate representation language model, etc. In pattern matching, patterns are predefined for their relevant domain. In synthetic approach, the natural language input NL is passed and the nodes are directly mapped in SQL query. The semantic method is similar to the synthetic method model. Here, the parse tree is generated for input NL question. Instead of mapping every node for query generation, it takes the required node. The intermediate representation language approach is proposed so that before mapping a sentence into a logical query language, this logical query language is first translated into a general database query language such as SQL. Pattern matching using regular expression for NLID. In this paper, the pattern matching approach has been used to develop NLID, and regular expression has been introduced to define patterns. Regular expression, regex or regexp for short, is a special text string for describing a search pattern recognized by finite automata. Different patterns are declared in RE, and if the natural language input matches to any of the patterns, then a SQL query is generated. Then the query is executed to the database and the required data is fetched. It is obvious that different users may ask the same question in many different ways, as the human brain is unpredictable, which means the same question may have different patterns. The main challenge is to detect the pattern of the given natural language and converting it into the right SQL statement. That is why RE is used to manage all the patterns into a single pattern and generate the SQL statement. In this approach, it is possible to include every possible question parts in a single RE pattern. Following are some examples of the same question with many patterns. What is the roll number of X? Give me the roll number of X. Show the roll number of X. For example, if we analyze the above input statements, we can find three common parts: question, answer, and the given part. Here, what is question part? The roll number, answer to be determined part of X, given part. Adding these three parts, we can get the pattern.
Now let's start with system architecture. The total system is based on pattern matching of the input text in natural language. After getting the natural language query from the user, the architecture has two types of tasks. First one is natural language or linguistic task. Pattern matching is used to be the NLP task. The next one is database query task. SQL statements are generated. If the tokenized inputs from the NLP task matches with the pattern, the system proceeds to the next step. Its main aim is to form relevant SQL statements for the matched items. It has some sub-tasks as well. As you can see, the figure below shows the overview of the system architecture. Let's move on to NLP task. The NL input query received from the Python interface is tokenized into several tokens. The tokenization means breaking down a sentence into words or tokens. It is an important feature in NLP. The token is the smallest element. It can be a word or different symbols such as comma, period, colons, etc. In tokenization, some of the characters as punctuation marks are removed from the sentence. The tokens can be used as input in many types of process like parsing and text mining. After getting the NL input, it is broken into tokens. If the input expression is executed correctly by the user, then it is to ensure if all these tokens are present in the regular expression pattern. If they do, the process will be successful. If not, it will not proceed further. As you can see, the figure shows the details of the system architecture. Now let's move on to the next slide, detection of focus. Consider the statement, what is the hometown of Sema? Here we have to identify the focus and the required clause. The information which is given and focusing on which we have to find out the required information is the focus of the expression. We call the other portion of the sentence required clause, as our required entity of the expression is mentioned in this part of the statement. In the above statement, what is the hometown of is the required clause. Sema is the focus clause. It is related to the SQL query of the database. We can get the focus entity from the where expression of the SQL. We get the required part from the select and from expression. An SQL query has these fundamentals. The relevant SQL query of the above expression is select hometown from about where name is equal to Sema. This select expression has further fundamentals. Select expression from table reference where the condition is. Our focus is the where condition in the input. In the where condition, we focus on the given value of a field. In our expression, Sema is the focus tuple. We can see it in the where portion of the SQL where name is equal to Sema. As we detected the focus as Sema, the rest of the input clause is the required clause. What is the hometown of refers to the required data that we need to extract using the focus. Select expression and from table references match these clauses. Using the focus Sema in the database, we can extract the required data of the result in the next stage of database query tasking. With this part of the task, the language processing task ends. From further task, we will work with database queries.
D. Database query task. We created a prototype database as shown in the figure. We have included 4 tables defining a student information system of an organization. The tables are student info, academic, supervisor info, other info. They provide all the important information of the student of the organization. Here is the SQL query that is generated. Now here is a question which will help us understand further. The question is, what is the name of roll number 1407025? The SQL expression for this will be SQL select name from student info, where roll number equal to 1407054. The regular expression pattern is matched with the input NL expression. Here we can see both of the expression matches. In the regular expression, the input and L tokens are present. What comma is question mark the question mark name of question mark roll number. Here they match. After the pattern matching, we look for the focus entity and required entity. We divide out NL expression into 2 parts. What is the name of required, which is the required cross, roll that is roll number 1407025, which is the focus. We form an SQL query in which the focus is included in the where expression and the non-focus part is in the select and from expression. Like that is select name from student info, where roll number equal to 1407025. Combining these two, our SQL will be formed. The student info is the table reference of the NLIT database. The name is the required entity that we need to identify depending on the focus of the where expression. Now in the next slide we can see the table 1, which is the regular expression pattern matching and SQL generation, as you can see. The next is the performance analysis. Now our natural language interface to database is evaluated on the student information retrieved domain. The whole system is divided into two parts, the linguistic part and the database part. The linguistic part is done with Python and transferred into MySQL format. We measure our evolution on the basis of 50 questions based on the table entity. The performance is mentioned by the accuracy, which is equal to A divided by B, where A is the number of correct translations to MySQL and B is the number of questions. In our system, if the user input question is matched with the pattern, it will give us a correct MySQL query and gives us the correct output. The system will not give answer only if the input is not matched with any of the pattern of the system. Table 2 shows the performance result of different type of queries, and table 3 shows the average of the results, as you can see. The conclusion. Now in this work, we presented a new way to translate given natural language to formal query using regular expression. We developed a scheme for query processing. The pattern matching is done using regular expression. In such system, no elaborate parsing and interpretation modules are needed. The system is easy to implement. Now using regular expression, a large number of possible patterns are predicted. Therefore, a maximum number of user queries are detected and matched with the pattern. The system will scan the input with the regular pattern, and if it matches the pattern, the SQL is printed as the output. Now this system will be adequate for the user who are non-technical or technical but non-experts in the database. Due to the splendid growth of the web, the NLIT has had sufficient successes to date that suggest that NLP based information access technologies will continue to be significant areas of research and development in information system. Now here we have listed down all the references for the preparation of our presentation, and that will be it for the presentation. Thank you.